Pleasant day to each and everyone. We are now on week 9 to 10, Mathematics 8, Quarter 1, and our topic is solving systems of linear equations in two variables. This is Mrs. Reina S. Corpus of UCNHS. Now, when we say systems of linear equations in two variables, we use this in order to solve problems like age problem, geometry problems, distance problems, work problems, and others. Now, in our picture here, we have here a problem, an example of a problem which could be solved using systems of linear equations in two variables. So the patient's age is thrice the age of the doctor. If the sum of their ages is 108, how old is each? So we will be answering this age problem later on as we move on to our lesson. So the most essential learning competency is to solve problems involving systems of linear equations in two variables. And we have three ways to solve systems of linear equations in two variables. First is by graphical method. So first, we are going to draw the graphs of each equations, and the point of intersection is the solution, if there is. So in our example here, x plus y is equal to 2. So the y-intercept is 2 and the slope is -1. So this is the graph for x plus y equals 2. On the second equation, negative x plus y equals 4. So this is 4. And the slope is +1. So the graph is this one. Now looking at the graph, the point of intersection, which is our solution, is -1 and 3. To check if our answer is correct, we substitute -1 plus 3 is equal to 2. 2 is equal to 2. On the second equation, negative times -1 is equal to +1 plus 3 is equal to 4. So this solution satisfies both equations. The second method is substitution method. So there are 4 steps. Solve for one variable in terms of the other variable in the other equation. Substitute the value of the first variable to the second equation. Simplify and solve the resulting equation. Substitute the value of b to any of the original equations to find the value of the other, and check the values obtained using the two equations. So we have here an example for substitution method. So our system is x plus y equals 2, negative x plus y equals 4. So this is the same with our graphical method a while ago. And let us see if we have the same answer. So in here, we will substitute the value of, we will get the value of y from the second equation. So when we transform this, it would become x plus 4. So we will be using x plus 4 instead of y. Now we substitute this to the first equation. So we have x plus y. Instead of y, we get x plus 4 equals 2. Then x plus x is 2x. Then plus 4 equals 2. Okay? 2x is equal to 2 minus 4 because you are going to add -4 on both sides. So therefore, 2x equals -2. Dividing this by 2, we have x equals -1. Now, for the second equation, to find the value of y, we substitute it. So I want to substitute it to the first. So x plus y equals 2. We have already the value of x, which is -1, plus y equals 2. Then y equals 2 plus 1, because by addition property, we add both sides +1. Therefore, y equals 3. So you can notice that we have the same solution as the first one. So y and -1 and 3. To check if our answer is correct, x plus y equals 2, we substitute it again to -x plus y equals 4. So our x is -1 plus 3 is equal to 2. And in here, negative times -1 plus 3 is equal to 4. So 2 is equal to 2 and 4 is equal to 4. If we check or we found out that both the solution satisfies both the equation, then our answer is correct. We now have the third method, the last method in solving systems. We have the elimination method. First, we rewrite both equations in standard form, ax plus by equals c. Whenever necessary, multiply either the equation or both equation by a non-zero number so that the coefficient of x will have the sum of 0. Add the resulting equations and simplify, then solve the equation. So we will be using the same example a while ago. And we are going to compare. So this is our example. So since this is the given, it is already in the standard form. Okay. Now, why 2? I will be showing you 2. The first one is that you are going to eliminate x by addition. So x plus -x is 0. Y plus y is 2y. 2 plus 4 is 6. Okay. In here, we are going to eliminate y. So we use subtraction. X minus -x is 2x. 2 minus 4 is -2. To continue, we divide both sides by 2. So y is now 3 and x is -1. So we came up with the same answer. Now it's up for you to choose later on which method you are going to use. Now for week 9 to 10, we have 3 activities and the fourth activity is solving problems. So the first activity is you're going to find the solution for each systems of linear equation using the graph. So in here, we have the equation of the systems x plus y equals 5, x plus y equals -4. So if you are going to graph this, the y-intercept is +5 and the slope is -1. So this is the graph for x plus y equals 5. Then we have -4. -4, the slope is -1. So this is the graph for for the second equation. So since the graphs are parallel, this is inconsistent system. Therefore, it has no solution. There is no point of intersection. For number 2, y equals x plus 3. So the y-intercept is 3 and the slope is 1. So this is the graph. Then 2y equals 2x plus 3 will also have the same equation with this first. So our line is coinciding. Therefore, it has infinite solutions. All the points that passes through this line are the solutions. Okay? And for number 3 example, x minus y equals -8. So since our y here is negative, we are going to transform this as y equals x plus 8. So therefore, the y-intercept is 8 and the slope is 1. So this is the graph for x minus y equals -8. For the second one, the slope, the y-intercept is 2 and the slope is -1. So this is the graph. And the point of intersection is -3, 5. So if we are going to check this, -3 minus 5 is -8. -3 plus 5 is +2. Okay, so this is just easy. If you're going to look at the graph, the point of intersection is the solution. If there is no point of intersection, no solution. But if there is only one line, there are infinite solutions. For activity 2, you are going to solve the following systems by substitution. So in here, example, x plus 3y equals 6. And x equals 4 minus y. So there is already a value for x. You are just going to substitute this instead of using x on the first equation. So instead of x, we use 4 minus y. Then you will just copy plus 3y equals 6. Then you combine like terms. Negative y plus 3y is 2y. Then 6 minus 4 is 2. You divide both sides by 2, therefore our y is 1. Now, to get the value of x, we will substitute the value in the first equation. So x plus 3y equals 6. Since our y is 1, x plus 3 times 1 is equal to 6. 3 times 1 is 3. Therefore, x equals 6 minus 3. And our value for x is 3. So the solution is 3, 1. Then finally, we check our answer on the two equations. So we substitute 3 as x, 1 as y. So 3 times 1 equals 6. And on the second equation, 3 equals 4 minus 1. So we will arrive at the same answer. So this solution is correct. Okay? So that's substitute me. For the third activity, eliminate me. So I will be showing you two ways. First is you are going to eliminate x. Since the second equation has number 2 as the numerical coefficient for x, therefore we multiply the first equation by 2. Okay, the whole equation by 2. 2 times x is 2x. 2 times y is 2y. 2 times 4 is 8. Then you just copy the second equation. Okay? Then you move on. 2x minus 2x is 0. 2y minus 3y is 5y. 8 minus 3 is 5. You divide both sides by 5, you will get 1. To eliminate or to find the value of x, so you look at y. The numerical coefficient of y on the second equation is negative 3 or 3. So you are going to multiply the first by 3. So 3 times x is 3x, 3 times y is 3y, 3 times 4 is 12. Then you will just copy the second equation. So to eliminate y, we use addition. 3x plus 2x is 5x. 12 plus 3 is 15. Divide both sides by 5, so we have 3. Therefore, our solution is 3, 1. Okay, and as usual, we are going to substitute the values of the answer to our given equations. And if you will arrive it as equal, then your answer is correct. Okay, now we will apply the word problem in the given problem that I have told you a while ago. And you could apply any method. Okay, you could use graphical, you could use elimination or substitution. So I will read the problem again and you analyze. The patient's age is thrice the age of the doctor. If the sum of their ages is 108, how old is each? So let us try to represent X as the age of the patient and Y as the age of the doctor. On the first statement, the patient's age is thrice the age of the doctor. So X is equal to 3 times Y. The second equation is if the sum of their ages is 108. So if you're going to add X plus Y, it is equal to 108. So we have now the systems of linear equations in two variables. Now, since there is already a value for X, which is 3Y, therefore, it is better if we use substitution. So, instead of X, we will be using 3Y. So 3Y plus Y is equal to 108. 3Y plus Y is 4Y. Divide both sides by 4. Therefore, the age of the doctor is 27 years old. To find the age of the patient, we are just going to substitute X equals 3Y. So 3 times 27 is 81. Therefore, the age of the patient is 81. So to check if our answer is correct, 27 plus 81 is 108. 81 or 27 times 3 is 81. So you get or you got the correct answer. For our activity 2, you will be having a performance task. You create a problem involving systems of linear equations in two variables. Write the solution to that problem using any of the methods. And for that, you will be graded according to these rubrics. So this will be the basis for your score. Okay? So I hope you have learned something from this week. And this virtual instruction is not possible without the help of the whole grade 8 math team. Enjoy learning math and have a nice day.